Recently, very important news were published about latest satellite technologies and a lot of news. The first news with us says, NASA's ion thruster know-how keeps satellites flying. In low Earth orbit, satellites face a constant challenge, a tiny amount of atmospheric drag that, over time, causes them to slow down and decay their orbit. To combat this, spacecraft rely on in-space thrusters to adjust positioning and boost orbits. However, most of these thrusters use heavy, expensive chemical propellants. This is where the game-changing ion thrusters come in, offering a more efficient and cost-effective solution for satellite operations. Orbion Space Technology, based in Houghton, Michigan, was established in 2016, recognizing a market need. The company set out to find innovative ways to either extend the lifespan of satellites in orbit or increase their payload capacity. This ambitious goal necessitated the development of a thruster that could operate efficiently with minimal fuel consumption, leading to the creation of the company's Aurora thruster. Hall-effect thrusters, an advanced ion propulsion technology, use electricity rather than chemical reactions to propel spacecraft. Orbion's founders saw the technology grow from an experimental concept to being regularly used on missions across the solar system. Still, the company had to turn to the experts to make these thrusters viable for satellite operators. NASA's Glenn Research Center in Cleveland leads the development of ion thrusters for the agency, designing and evaluating thrusters for missions like Dawn and DART and the agency's Gateway Lunar Space Station. Orbion entered into a data usage agreement with NASA Glenn to receive detailed information from the development of these engines and a non-exclusive evaluation license. One of the reasons Orbion turned to NASA was its advancements in materials research for ion thrusters and the Glenn-developed cathode heater, which improves electrical efficiency and operating life. This work resulted in Orbion's Aurora thrusters being just as capable as those that NASA builds for its deep space science and exploration missions. Orbion has since sold several Aurora thrusters to government and private sector companies, including a recent contract with a large commercial satellite operator for its new constellation of Earth-observing spacecraft. The second news with us says, X-ray satellite XMM Newton sees space clover in a new light. Astronomers have discovered enormous circular radio features of unknown origin around some galaxies. Now, new observations of one dubbed the cloverleaf suggest it was created by clashing groups of galaxies. Studying these structures, collectively called odd radio circles, in a different kind of light offered scientists a chance to probe everything from supersonic shock waves to black hole behavior. Esra Bulbul, an astrophysicist at the Max Planck Institute for Extraterrestrial Physics in Garching, Germany, who led the study said, "This is the first time anyone has seen X-ray emission associated with an ORC. It was the missing key to unlock the secret of the cloverleaf's formation. Until 2021, no one knew ORCs existed." Thanks to improved technology, radio surveys became sensitive enough to pick up such faint signals. Over the course of a few years, astronomers discovered 8 of these strange structures scattered randomly beyond our galaxy. Each is large enough to envelop an entire galaxy, sometimes several. Bulbul said the power needed to produce such an expansive radio emission is very strong. Some simulations can reproduce their shapes but not their intensity. No simulations explain how to create ORCs. When Bulbul learned ORCs hadn't been studied in X-ray light, she and postdoctoral researcher Xiaoyuan Zhang began poring over data from extended Röntgen survey with an imaging telescope array, an orbiting German/Russian X-ray telescope. They noticed some X-ray emission that seemed like it could be from the cloverleaf, based on less than 7 minutes of observation time. That gave them a strong enough case to assemble a larger team and secure additional telescope time with XMM Newton, an European Space Agency mission with NASA contributions. Bulbul said we were allotted about 5.5 hours, and the data came in late one evening in November. I forwarded it to Xiaoyuan, and he came into my office the next morning and said, "Detection," and I just started cheering. The X-ray emission traces the distribution of gas within the group of galaxies like police tape around a crime scene. By seeing how that gas has been disturbed, scientists determined that galaxies embedded in the cloverleaf are actually members of 2 separate groups that drew close enough together to merge. The emission's temperature also hints at the number of galaxies involved. When galaxies join, their higher combined mass increases their gravity. Surrounding gas begins to fall inward, which heats up the infalling gas. The greater the system's mass, the hotter the gas becomes. Based on the emission's X-ray spectrum, it's around 15 million degrees Fahrenheit, or between 8 and 9 million degrees Celsius. That measurement let us deduce that the cloverleaf ORC is hosted by around a dozen galaxies that have gravitated together, which agrees with what we see in deep visible light images. The team proposes the merger produced shock waves that accelerated particles to create radio emission. Kim Weaver, the NASA project scientist for XMM Newton at NASA's Goddard Space Flight Center in Greenbelt, Maryland, who was not involved in the study said, Galaxies interact and coalesce all the time, but the source of the accelerated particles is unclear. One fascinating idea for the powerful radio signal is that the resident supermassive black holes went through episodes of extreme activity in the past, and relic electrons from that ancient activity were re-accelerated by this merging event. While galaxy group mergers are common, ORCs are very rare. And it's still unclear how these interactions can produce such strong radio emissions. Bulbul said mergers make up the backbone of structure formation, but there's something special in this system that rockets the radio emission. We can't tell right now what it is, so we need more and deeper data from both radio and X-ray telescopes. The team solved the mystery of the nature of the cloverleaf ORC, but also opened up additional questions. They plan to study the cloverleaf in more detail to tease out answers. The last news with us says, NASA doubles down, advances 6 innovative tech concepts to new phase. NASA's Innovative Advanced Concepts Program, or NIAC, has selected 6 visionary concept studies for additional funding and development. Each study has already completed the initial NIAC phase, showing their futuristic ideas, like a lunar railway system and fluid-based telescopes, may provide fresh perspectives and approaches as NASA explores the unknown in space. The NIAC Phase 2 conceptual studies will receive up to $600,000 to continue working over the next 2 years to address key remaining technical and budget hurdles and pave their development path forward. When Phase 2 is complete, these studies could advance to the final NIAC phase, earning additional funding and development consideration toward becoming a future aerospace mission. John Nelson, NIAC program executive at NASA headquarters in Washington, said. These diverse, science fiction-like concepts represent a fantastic class of Phase 2 studies. Our NIAC fellows never cease to amaze and inspire, and this class definitely gives NASA a lot to think about in terms of what's possible in the future. The 6 concepts chosen for 2024 NIAC Phase 2 awards are: Number 1, Fluidic Telescope. Enabling the next generation of large space observatories would create a large optical observatory in space using fluidic shaping of ionic liquids. These in-space observatories could potentially help investigate NASA's highest priority astrophysics targets, including Earth-like exoplanets, first-generation stars, and young galaxies. Number 2, Pulsed Plasma Rocket. Shielded, fast transits for humans to Mars is an innovative propulsion system that relies on using fission-generated packets of plasma for thrust. This innovative system could significantly reduce travel times between Earth and any destination in the solar system. Number 3, the Great Observatory for Long Wavelengths could change the way NASA conducts astronomy. This mega-constellation low-frequency radio telescope uses thousands of autonomous smallsats capable of measuring the magnetic fields emitted from exoplanets and the cosmic dark ages. Number 4, radioisotope thermoradiative cell power generator is investigating new in-space power sources, potentially operating at higher efficiencies than NASA legacy power generators. This technology could enable small exploration and science spacecraft in the future that are unable to carry bulky solar or nuclear power systems. Number 5, flexible levitation on a track would be a lunar railway system, providing reliable, autonomous, and efficient payload transport on the Moon. This rail system could support daily operations of a sustainable lunar base as soon as the 2030s. Number 6, Sciencecraft for outer planet exploration distributes quantum-dot-based sensors throughout the surface of a solar sail, enabling it to become an innovative imager. Quantum physics would allow NASA to take scientific measurements through studying how the dots absorb light. By leveraging the solar sail's area, it allows lighter, more cost-effective spacecraft to carry imagers across the solar system. NASA's Space Technology Mission Directorate funds the NIAC program, as it is responsible for developing the agency's new cross-cutting technologies and capabilities to achieve its current and future missions. Thank you very much for watching. Goodbye.